Hello and welcome to the MATLAB programming NPTEL course. We are in module 1, which is Introduction to MATLAB. Lecture 1.2 is going to cover arrays and matrix operations in MATLAB. In the previous lecture, we had given an overview of what MATLAB is. In this particular lecture, we will learn how to build arrays, which we had started off in the previous lecture itself. We will go over that again. We will talk about colon notations and we will talk about array operations and array functions. As before, there is a video on the MATLAB website that you can watch, the link for which is provided over here. The video is called Working with Arrays in MATLAB, and I suggest that you also look at this video in addition to this NPTEL lecture. Okay. So, let us look at building of MATLAB arrays and vectors. Okay. In the previous lecture, we had looked at how to build a row vector if we have a row separated, elements of the row separated by commas, we are going to have a row vector, and if instead we were to separate it by semicolon, we are going to have a column vector as shown over here. Okay. So, I am getting an error. The reason why I get an error is because I forgot to put a semicolon over here. So, it is trying to build a vector by having a 1 in the first row, and in the second row we have 2 elements, and we cannot build a vector of that size. So, instead if we were to have semicolons as shown over here, we are going to get a column vector as seen over here. That leads me to the next thing, and that is that we do not have to build vectors on arrays by having each and individual elements. We can use previously defined vectors and arrays to build a particular matrix also. So, let us say we were to define C as let us say identity matrix of size 3. Okay. So, we will get C as EYE3. EYE is a command in MATLAB that will build an identity matrix. Okay. So, what we have over here is a vector A that is a 3 by 1, a 1 by 3 vector, and a vector C or a matrix C that is a 3 by 3. So, if we write say D equal to A semicolon C, this is the result that we are going to get. So, the first row is what our vector A was, and the next 3 rows are going to be what our C, the array C was. So, this is how we have built our matrix D. Let us say we try to do this A comma C. What is going to happen is we are trying to build a matrix which, by combining an array which has 1 row with a matrix that has 3 rows, which is going to result in an error, the similar type of error as we had seen earlier. This is an error in horizontal catenation. That means we are combining 2 arrays horizontally, and there is an error in combining that. Recall earlier that we had what is known as a vertical catenation error. However, instead if we were to give E equal to B comma C, that is going to work, because this is our vector B which has 3 rows, and we are horizontally catenating it with another vector that has another matrix that has 3 rows, and we will be able to do that. The next function is transpose of a vector or a matrix, and for transpose you have to use apostrophe, so or dash. So, if we say A dash, we are going to get, instead of a column vector, instead of a row vector, we are going to get a column vector. And just as we did before, we can construct a matrix now by saying A dash comma C. Now, A dash, what is going to happen is, first we are going to have the transpose. So, first MATLAB is going to calculate the transpose of A. A, recall, was a 1 by 3 array. So, if we transpose the 1 by 3 array, we are going to get a 3 by 1 array. So, now 3 by 1 array can be horizontally catenated with a 3 by 3 array. Why? Because we have the same number of rows in A prime as well as in C. So, if we are giving this particular command, as you will see later, we will see that we are able to construct the matrix F. So, F equal to A dash comma C enclosed in square brackets. I press enter and we are going to get our matrix F. Okay. Now, let us say we wanted to get any particular element of this matrix. So, let us say we wanted to get this particular guy 2 over here. This is row number 2 and column number 1. So, we can get this by saying F not square but round brackets F2 comma 1. So, that is row number 2 column number 1, and if we press enter we are going to get this particular element. Likewise, let us say we wanted to get this element, that is now in F, it is in row number 3 column number 2, and we press enter and we are row number 2 column number 3, row number 2 and column number 3, and we are going to get this particular element. Okay. So, when we gave this command, it is row number 2, the first guy is the row and the third column over here, that is column number 3. When we gave this command, that is row number, that is going to be row number 3 and column number 2. Okay. So, that is what we are going to get. Now, if we were to give, let us say F 5 comma 5, now as you know that F 5 comma 5 does not exist because we do not have 5th row nor do we have 5th column. If we give this, we get an error which says index exceeds matrix dimension. So, that is because the size of that matrix was 3 by 4 and we were trying to query F 5 comma 5 that does not exist. Okay. So, I will clear the screen over here. Now, if I wanted to find the size of that matrix, there is a very simple command called size. If I give size F, it is going to return to me the size. Okay. The number of rows is 3 and number of columns is 4. Okay. So, that is about building the arrays. I will next talk about colon notations. So, colon notations is, so colon in MATLAB is nothing but 2, or say we want to go from say 1 to 5, we use a colon 1 colon 5, and let us look at that over here. So, if I give 1 colon 5, I have 1, 2, 3, 4 and 5. Note that when we use colon notations, MATLAB creates a row vector and not a column vector. We can always assign this to any other variable. So, let us say we were to say z equal to 1 to 5, this is what we are going to get. Now, let us say we wanted to have 1 to 5 in steps of 3, we will give this as y equal to 1 colon 3 colon 5. Okay. So, in steps of 3 means the first guy is 1, second guy is 1 plus 3, that is 4, and the third guy would be 1 plus 4 plus 3, that is 7. However, 7 goes beyond the value 5. So, 7 will not be admissible over here. So, if I press enter, I get 1 and 4 as the 2 elements in this particular vector. Now, if I were to do y equal to, let us say 2 colon 1, what is going to happen? Okay. Now, 2 colon 1 means we want to go from 2 to 1 in steps of 1. The first guy itself 2 is greater than 1, and therefore, we are not going to get anything. We are going to get a blank matrix. Okay. So, y becomes an empty matrix which has 1 row and 0 columns. Note that MATLAB is not giving an error, MATLAB is giving an empty matrix. Okay. Likewise, if we were to have y equal to empty square brackets, we are going to get an empty matrix. So, that is a 0 by 0 matrix, it is an empty matrix. Okay. So, empty matrices are also matrices in MATLAB of size 0. Keep that in mind because that is an important information. Okay. So, we have kind of covered what colon notations are. just as we had seen earlier, we can query any part of a vector or an array using elements of that array. Likewise, we can query multiple parts of that array. So, let us look at the array F over here, and let us say we wanted to get second row and column number 2 and 3. How we can do that is F row number 2 and column number 2 and 3, that is 2 colon 3, and we will be able to get 0 and 1 over here. Likewise, if we wanted row number 2 and 3 in column 2, we will write F row number 2 to 3 in column number 2. So, 2 colon 3 means row numbers 2 to 3 and column number 2. Press enter, this is what we get, that is 0 and 0. Okay. Let me clear the screen again. Okay. In order to query any of the elements or any of the submatrix, the command that we are going to use is F p comma q, where p represents all the elements that we want to query and in a row, and q all the elements that we want to query in a column. So, if we were to say 3 comma 3, that is going to be F 3 comma 3, which is 0. Likewise, we can say p equal to 0, sorry, p equal to 3, q equal to 3, and if we were to query F p comma q, we are also going to get F 3 comma 3. Okay. Now, instead, if we were to say p is 1 comma 2, and if we say F is p comma q, what is that going to do is we are going to query the first and second rows of F and the first column of F, because p is 1 comma 2 and q is 3. Okay. And this is what we are going to get. So, F what we queried is, because p was 1 comma 2, so first and second row, q was equal to 3, so column number 3. So, first and second row of column number 3 is what we get. Okay. Likewise, we can say F 1 to 2 and 3 to 4, and this is what we will get. So, again let us type F over here. So, what we have is F rows number 1 and 2 and columns number 3 and 4. So, we are going to get this particular submatrix as our ANS. Okay. So, what now we have covered so far is how to build an array and how to use column notations both to build an array as well as to get parts of an array or subvectors in an array or a submatrix or a sub array in that particular array. Okay. These are going to be extremely powerful tools that we are going to use and leverage in the rest of this particular course, and I encourage you to look at the videos that are there on the MATLAB website as well as try these things out yourself. At the end of this particular module, we will have a certain set of examples that you can try. These examples will be split based on the various lectures, and I would encourage you to start going through these particular examples right away in parallel to doing this video lecture. Okay. So, let us go to the next slide. Okay. This is what we have used in order to build the arrays. We use the comma and semicolon in order to build an array using numbers as we have shown over here. In addition to that, we can also use existing arrays if they are of a correct size in order to build arrays as well. Okay. In addition, we have also seen this function EYE, that is to create a n by n identity matrix. In addition to that, there are several other array building functions such as ones, zeros, diag, array_nd, rand_n, magic, Hilbert, and so on and so forth. So, I will quickly show you how to build how to use ones. If we give the command ones 2 comma 4, we are going to get an array containing all ones of 2 rows and 4 columns. This is what we see over here, and that will be assigned to a variable ANS. Okay. If I give the command say x capital X equal to zeros 2 comma 1, we are going to get 2 rows and a single column with all of the elements getting the value 0. So, that is what these matrix building functions are going to do. Let us look at another function called rand. Rand is basically uniformly distributed random numbers. So, if I give rand without any arguments, I am going to get a single random number. If I give rand with 2 arguments 2 comma 3, I am going to get a 2 by 3 matrix of random numbers. These are uniformly distributed random numbers. That means you will get values between 0 and 1 with equal probability. Okay. So, these are the various array building functions. We also saw in the previous lecture some of the basic mathematical expressions, the scalar expressions where logarithm, exponent, power, sine, cos and so on. There are matrix operations, plus, minus, multiplication, division. These are not scalar operations, but matrix operations. So, what I mean by that is that we need our 2 vectors to be commutative. So, let us bring out our vector A. Okay. If I do A star A, we are going to get an error. That is because a 1 by 3 matrix cannot be multiplied by a 1 by 3 matrix. The number of columns of A has to be equal to the number of rows of the one that you are multiplying that A with. So, if we give A, we get an error saying that error inner matrix dimensions must agree. The reason why that happens is A is a 1 by 3 vector. Let us say we have a vector B. Now, B was a 3 by 1 vector. So, we can indeed multiply a 1 by 3 vector with a 3 by 1 vector. So, you can indeed do A star B, and that is going to be a matrix multiplication. Okay. Let us look at the vector, the matrix E. E was a 3 by 4 matrix, whereas A is a 1 by 3 matrix. So, indeed we can multiply A with E. So, if we do A multiplied by E, we are going to get a 1 by 4 vector. Okay. And this is what we get when we do A multiplied by E. Again, the rules of matrix multiplications are indeed available, are applicable over here. Okay. The slash, we will not go over the slash currently, that is because it is a little bit more advanced at this stage. This slash is going to be either, depending on what slash you use, either it is going to be a left division or a right division. What left division and right division means is something that we will go in one of the later modules. We are not going to cover that in this particular module. So, if you are going to use a slash, use that with care and wait until the next module that is going to cover the slash operation. The next one is a power operation, and that operation is the caret sign. The caret sign is again a matrix operand. So, we can't use that caret for a non-square matrix. It has to be used on a square matrix itself. So, if we do A caret 2, it is same as A star A. These are the same commands, and as we had seen, A is not commutative to itself under multiplication. However, instead if we had a 3 by 3 matrix, let us say let us say R equal to rand 3 comma 3, okay, that would be commutative in under power as well. So, R to the power 2 is just going to be R star R. So, it is a matrix multiplication, and this is what we will get. Okay. What I am showing over here also are the scalar operations and equivalent vector operations. So, if we do exp of an array, we are going to get element by element exponential. If we want a matrix exponential, we want to do expm. Okay, let us look at that. Let us see if we had say a matrix D equal to 1 0 2 1, and if we were to do, let me just clear this CLC. okay, 1 0 2 1. If I was to do exp of d, I am going to get each element is going to get its exponent. If instead if I were to do exp m of d, this is what I am going to get, and this is a matrix exponent, and matrix exponent has its own rules, something that we are not going to go over in this particular module, but this is an individual element by element exponent, and this is a matrix exponent, and as you can see that the matrix exponent is different than element by element exponent. Okay. In addition to that, there are some other commands, that is sum, prod, cumsum and cumprod. Let us look at those commands also. So, our matrix A was 1, 2 and 5. Sum is going to be just sum of the elements of that particular matrix. So, 1 plus 2 plus 5. Cumulative sum is cumsum, and if we give cumsum of A, what we are going to get is first element is going to be itself, the second element is going to be 1 plus 2, the third element is going to be 1 plus 2 plus 5. Okay. So, we get 1, 3 and 8 as the result of cumsum. Likewise, we have prod. Prod is just multiplication of all the elements of A, and cumprod is multiplication of all the elements until that particular point. So, cumprod of A is 1, then 1 multiplied by 2 and then 1 multiplied by 2 multiplied by 5, and this is the result that we get. Okay. This command size we have already seen, length is length of a particular array. So, if we have an array which is say a 5 by 1 array, and if we give the command length, it will return the value of 5. Okay. Again, these are things that you should try out in MATLAB. Okay. Now, in addition to the matrix operands, we also have an element by element operand. Recall the difference between log and log m. If we wanted to do this with multiplication, division and power sign, we have an operand called dot star, dot slash and dot caret, which will operate on each element, and let us look at that. Let us define our variable a as 1, 2, 3, 1. Okay. If I do a star a, we are going to get a which is going to be multiplied by itself, and that is a matrix multiplication. However, if I am going to do a dot star a, it is going to be each element of a multiplied by itself. So, we are going to get 1 multiplied by 1, this is 1, 2 multiplied by 2, that is 4, 9 and 1. This is what we see when we do the result over here. Okay. Exact same thing is what you can expect with a caret 2, okay, and that is going to be same as a star a, squaring of a. Okay. And likewise, if we want this similar to a dot star a, that is going to be a dot caret. So, a dot caret 2 is going to give us 1 4 9 1, that means each individual element of the array has been squared. Okay. So, these are the basic mathematical operations. Again, for people starting out with MATLAB, some of these operations are a little bit difficult to grasp. So, I would strongly suggest that you go and try out these operations, take a pen and paper along with you and see what the matrices that you are forming and what results you are going to get. With that, I come to the end of this particular lecture, and I will see you in lecture 1-3. Thank you.